Hello and welcome to another stream for a compiler demo of the Odin programming language. It has been quite a long time since the previous demonstration. The demonstration last one was in February time, so I've been slacking even though there has been quite a few releases since then. So for all the newcomers here, the Odin is the programming language that I've been developing for quite a while now. And it is available here at github.com/odin-lang/Odin. This is kind of the thing here to show what's going on. Here are previous demonstrations and a few other things on here as well. So to note, I've been writing up some basic tutorials and frequently asked questions for Odin, which is available. The tutorial is available on the Handmade Network wiki page here, and you can see how you can get through, and there's loads of different topics to talk about how things work. It is not fully complete yet, but it's just general overview of the language. For instance, you could say, okay, so how does the fall through statement work? So here we go, this is the fall through, so this makes it act like C would, which, because in Odin, breaks on by default. And it's a pretty nice, useful thing. There is also a frequently asked question, which is here. So you can see what is the history of this project. If you're here from the start, you'll know I got very drunk one night on rum and started making my own language because I got frustrated with C++ so much. And yeah, that was how it got started. It was kind of a little Pascal clone with begin and end because I thought, why not? And then I just went straight to the color braces and so what. Again, this idea was just to be, I tried to make a better C, and it was all like that. So the questions about who my influence is, again, Pascal, C, going over on have been huge influence for me. So again, Niklaus Viet or Worth, however you want to pronounce his name, I don't really know. I guess he's Viet because he's he's Swiss, I think, isn't he? Yeah. And then you got Rob Pike as well. So these are some of my kind of idols. Some great questions in here that many people commonly ask me, and I can just lead them directly to the questions, which is good. It's like some of the favorite ones is, why doesn't Odin have feature X, or why doesn't Odin have exceptions? Is that Odin object-oriented language? Why is there overloading in Odin, or a better way to put it is, why is there explicit but not implicit? There's some really good stuff like, what is this? What is my favorite one? The one I get asked quite commonly is, what does : mean? But so there's some really common things here to explain, and it's very interesting. So if you've got any more frequently asked questions, I may actually add them to the list. So if you want to get the latest release of the language itself, you can go onto the GitHub page, click on the releases, and here we go. So you can go to the version 0.9.1. You'll see on this list here, there is 0.91, which is a few bug fixes from a few minutes ago. And then 10 days ago, I released 0.9.0, which has a few lists of quite a lot of features. There's also the 0.8, which had a lot of new features in it as well. And then there's also the 0.7 releases, which has a lot of new features in it too. So I want to cover kind of most of the new general features in the entirety of the language, and even if I've gone over them again, I kind of want to explain why there's been quite a lot of new changes. So let's go and explain. So let's go straight to here, and this is the demo file, which is available to run. And if I click run, at the moment you can see it runs it. There you go, built on a run, quite fast. So here we go, is the demo file. At the top, you'll notice it says package main. Now, in Odin, I've landed on a way of designing how libraries work in the language. And it's taken me, to be honest with you, about 2 years to figure this out. What is the best way of approaching this? And it's been pretty much just full of compromises. And I've kind of come to the conclusion that there is no perfect solution that would meet the requirements that I wanted initially for the perfect library system for the language. And I kind of came to the best idea, which is technically the modular approach, or a modular with an A at the end, or the Oberon, or the Go approach to how libraries should be handled, which is the package system. The way about this is, when I was looking for how libraries should be handled, is I was kind of thinking, should it be focused around the file or the directory? The reason for this is, it'd be great if you could completely abstract everything, but unfortunately you have an operating system to deal with. And the operating system has a hierarchy already built into it, based around files and directories. And you kind of have to think, okay, so what is the library based around in that sense? You've kind of cannot get away from this idea of the actual file system. So there was kind of two kind of camps I kind of came down on. One, the camp was the Python camp, and the other camp was the Go camp. The Python camp was that you imported a file, and that file was its namespace which you imported. And the Go camp was that you imported a directory, and that directory contained multiple files which they would all collect into one big namespace. So they both had their own advantages, but I finally settled on the Go approach, which was set the directory as the actual library itself. The main reason for this was that the Python approach, with a single library file, was not particularly useful in practice. And I've used Python a lot professionally as well, and there are some severe issues with the language when you're dealing with it. So one of the tendencies people tendly do is they import particular entities from a package rather than reference the packaging by name. This means that it becomes very difficult to understand where something came from when you're reading code, because then Python, which it naturally allows, you kind of want it to do this as well, is that you want to export the things you've just imported. So when you import another file which had imports in something like this, those things get exported as well. So when I was trying it with the single file approach, I wanted things to be local, and I'd want things to be explicitly exported otherwise. It started to become very annoying, and it wasn't very useful. So when I wanted multiple file libraries, it was kind of like, okay, I've now got another hierarchy I've got to deal with, where it just became a mess. And the directory approach, which I'm going to explain by demonstrating it, by going to the syswin32 library, might be a good idea. So in here, we've got the syswin32 library. You'll notice in this folder here we have two files. We have windows.odin and wgl.odin. The wgl file in this case is just some of the OpenGL procedures that I use, which come part of the Win32 library but requires the OpenGL library. There's also the Windows library, which contains a lot in here. This will need to be split up eventually, so like the kernel32 will be in one file and user32 and stuff like that. But this is very useful. So both of these files, when you import it, will be treated as part of the package. So this sounds a bit, why would you want to do that? So a good example of this, other than the thing I've just shown, would be the runtime package, which is, again, I'm just showing the core stuff at the moment. So I have 3 files in here. I have core, which has a lot of the core runtime stuff that I require, like for instance the type information, the context layout, how I handle maps, other fancy things such as well, like for instance the copy procedure, the pop procedure, unordered remove, stuff like this. There's also internal, which is stuff like aka printing out a string and such, which the runtime will require, bounds checking in here. And then there's also operating system specific things. In this case, this is for Windows and AMD64, where I'm having memcopy, memmove, and memset defined, and this is all done in the runtime. But the thing is, you notice every single file has the name package runtime at the top. Now this is to say, okay, this is the name of the package, and they all got the same name. That name is going to be unique on a per project basis, because this is actually the prefix what happens when you're linking. So for instance, this, if we take this function for example, in the source code, when you're linking like the assembly, it'll have this name. It will be runtime dot print u64. This is actually a solution I wanted to have because I wanted the ability to have consistent linking names, and it's really, really difficult to do. There are pretty much 3 approaches to this. The first one is do not care about consistent linking names unless the user explicitly states they need an explicit one. That is a solution. Personally, I do not like that approach. That's why I didn't go with it. The other approach is you go use the file system itself. But if you use the file system itself, you need an absolute position to be relative from. So you could have like, okay, this is the root, or this is the path, and everything that's nested within there will go from that root and base the prefix name from its directory. For instance, this could be like core, it could be like Odin / core / runtime / thing, and that would be its like linking name. I didn't particularly like that either, because in Go, this is very, very annoying when you're trying to set up a new project. It's not necessarily that annoying, it's quite useful in times, but every single project requires that you set up the Go path to use it. And this is the reason it has an absolute position where all the relative directories can base their names from. Now there is the third approach, which is easy enough, which is literally just say this package has this name, every single link name will start with this. That will be its link name. And that's the way of getting around it. And this may sound annoying, like, oh, what if I have a library that has the same name as me? My first question is, just rename the library, or maybe don't use such a generic name. It's one of those where it is a solution to a problem that I particularly had, and it was the best compromise that I could come up with. And I can't think of any other better one, to be honest with you, either. I've researched this for quite a long while. But yeah, if you want any more questions about how this package system works, because I've already spoken this for about nearly 12 minutes now, this is quite a difficult problem. And it's not easy. There are loads of compromises about what things you value over different things, and I think the approach of having the directory as the library, the package itself, is the best compromise. I could show an example of a project that I was working on, and I'll explain why this is quite useful. So here's my little, I've got a little data viewer project at the moment. I won't run it or anything. But in here you can see I've got a package called ABF. And in here there's 3 different files, which is for the format, the parser, and a writer. And they're all in here, and they're separated by files. But when I import this, it'll only import the directory, and everything will be, okay, this is great, it's part of the package. I have a free type library here. And in free type, I have the Odin stuff here, which is the Odin directory. And this contains all the free type definitions. But I also have a library for it as well. So this is a .lib. So when you're doing an import for this foreign lib, which is here, I'll explain more about this later, because this is a new feature. It'll actually just import it relative to here. So all of the external stuff is relative to this directory. And that's quite a nice way of doing it. So you just walk it around. And also I have the actual C stuff in here originally. So it's quite nice to use the directory. It naturally goes this way. Same with the GLFW stuff. It's all in there. STB. I've got like the STB library here, which is for Sean Barrett's image loading and writing, well, image loading the library at least. And I've got the .lib next to it. It's, again, very useful. So that's why I've done it that way. So let's get on and talk about some other features in the new language. Let's get straight to this new demo. Let's close that and do that. So let's just do this full screen for people, and let's go through here. So the first thing you may notice is the imports. The imports are importing a file. The core bit here means we're importing from the core collection. This is pretty much just like an explicit search path. If you removed that, it will go relative. So without a library collection like prefix, it'll go to the relative file from this current file itself. So these are all these fun things, and you notice it's not doing the .odin anymore because it's just the package. Here's a when file. So I got the OS thing, and it's saying OS if this equals Windows. So this is a compile time if. We can import these actual packages as well. That's great. Some other thing here are the new on this procedure here. There's also an attribute. So this is saying I just want to actually set the explicit name for this would be general stuff. So it overrides the main.general stuff to be just general stuff. Very useful thing to have. So there's attributes in the language. If anyone wants some more explanation about them, please just say in the chat. I can go over them later. So some basic stuff here. So this has already been in the language for quite a while. You can have inline statements with do. So if you want a short, like if true, do return, this is quite useful to have. Because sometimes you really just don't want to have a full new brace. It is sometimes quite useful to have it quite in line. Sometimes not. It's one of those optional things. Even though I'm not a big fan of having multiple ways to do the same thing, this is kind of one of those like, yeah, it's kind of useful to have it approaches. Another thing is I do not have plus plus or minus minus in the language. I just go for this. The main reason for this is I do not like it as an expression because it causes issues with understanding the order that would be executed in. So for example, if I had plus plus as an expression, if I was doing something, let's just say this was an expression like this, and we did this, it was something like this, ignoring the other variables here. So the question is, what order would this be evaluated in? Now, even if this was extremely well defined, this is not at all obvious to the reader what is happening. So this is, you would say, okay, don't allow this. You shouldn't be doing this, is what's saying. But I'm like, okay, you shouldn't be doing this. I'm not going to allow it. So then you'd be thinking, okay, we should only allow it to be a statement. And then my next question is, if you're just allowing it as a statement, then why don't we just do plus equals? Now Go does this where plus plus is as a suffix. It's the only one it allows, and it's a statement. But the reason it has it is for a for loop. So in Go you can have something like this, and you go x plus plus. In Odin, this thing, I'll show where the new way of writing this. You could write it like this. That's one way of doing it. Or the way I would now do it in Odin, which I'll show in a few minutes, would be something like this. And there's no need for this plus plus anymore, unless you're being explicit about, oh, I need to go every 2. There's no need for it. So there you go. The second thing is casting syntaxes. This is probably quite old still. There's 2 ways of doing it. You can either treat it as a function call, where you've got the type on the left, and you do the type as like the procedure value, like here, or we can use this as the operator, cast operator. This is mainly an aesthetic thing, because sometimes it's actually easier to read it when it's with a cast operator, which is like this. Sometimes it's easier to read it when it looks like a function call. It is more of a, yes, there's 2 ways of doing it, but it's kind of a nice aesthetic thing. Some of the things here, for instance, I removed all of the underscore val of and just went for the size of, line of, ID of, type info of, and there's also type ID of as well, which we'll get onto what type ID is in a few minutes. There's also a nice little built-in procedure. The one is called expand to tuple. This may sound bizarre, but it's kind of useful in certain circumstances. So Odin doesn't actually have any proper tuples in the language. They're not user level, but there are, tuples always kind of like a second class citizen in that they always get destructed all the time. So as you notice here, this tuple already becomes expanded to 2 values. Yeah? So these are kind of a bit weird. So for instance, you have this struct. We have elements int and a ball in it. and we've got the values here. So if you expand a tuple, it will take every single element field in this structure and separate it out. So if we do the run and go to the top here, it will say, look, we've got this thing here, which has got x equals 1, 2, 3, b equals true. And then we've got split here, we've got the x, y value. And also the printf will handle the tuple stuff here, will auto expand as well. So it works out correctly. That's great. So that's a little expand to tuple. There is now also the open range. So the open range here is, again, as I said, is just a dot dot. There used to be two ways of doing this. It was a dot dot and a triple dot. I got rid of this because it was actually a bit confusing and not very useful to read. I also thought, okay, this is actually one of those, I'm still not decided what the best approach to do this is, but so I'm just sticking to the single open range, which is double dot. So 0 to 2, inclusive, so 0, 1, 2. This range also works in switch cases as well, which I can probably show out later. If I don't know if it's actually in this demo, I cannot remember, but it's there. There are, okay, some other things like multiple size booleans. This is very useful for interfacing with like another language like C, or even if you want to explicitly state, okay, I need a boolean of a certain size. So by default, bool will be a byte. But if you want to explicit by saying it's a byte, you can do that, or 16 bits, 32 bits, or 64 bits. And they all print out exactly as you expect, because that's exactly what I want. It's very useful to have this. The other feature I've implemented is distinct types. Now this may sound a little bit weird to a few people. So these are compile time asserts, which can be shown with this hash assert. If I got rid of the hash, this is now a runtime assert. Now that's a compile time assert. They are slightly different. So you can think anything with the hash at the front means it's a compiler directive in a sense. You could think that. So explain these distinct types. This was something I had to kind of think, okay, how would this work with the system? So colon meant this is a constant value declaration. And when you're doing a constant value declaration, it kind of had to be, this is more of a naming a value rather than making it just the value distinct for the name. So explain this here. So I've got this new type. I'm just going to int 32, and it's actually just, it has the value of I32. This is just an alias of this type. Previously, I used to have something called like a type alias directive, but this was just not particularly clear. So I thought, okay, let's just do by default and have distinct in this case. So I want to make this a distinct type, do that. Now, if they are something special, such as the struct, union, enum, proc, or a bit field, by default, they will be distinct. One of the reasons for this is one of them is it prevents accidental references, because if it's just a reference of a net struct, you cannot have it being recursively defined within itself. So that's a cycle loop, type cycle loop. That's correct, yeah. The other is, there's very rarely a case that you want an anonymous struct, and by default you always want it named. So it's just stupid that you'd have to write distinct every single time. Go for the default case to be the default, of course. Now, someone's asking in the chat, that's a very, very important question. If I did my struct 2 equals to my struct, are these the same? Well, or are these different? Because this is just a name, you're just aliasing the name. It's not actually a struct definition. So I can assert that these will be identical. And there you go, the compiler hasn't errored at me. If I said they are not identical, it says, okay, compile time assertion, these are not the same. And that's what I expect, and it's what also makes it feel right as well. Because these are just names as well, even though they're named values, it should work the same. Does that make sense? Good. This next feature, which is another compile directive, which is kind of controversial. I wasn't sure if I should implement this or not, because it's getting borderline C preprocessor, but it's in some cases I think it will be useful. In this case, it checks to see if a value, name, identifier has been defined. In this case, I've defined X. And it will say, okay, we're going to check, is the identifier X been defined? And if it has, we go into this code block. If it hasn't been defined, it will go into the other code block. And this is a compile time check. The next is Y. Now, it's going to search Y in all of the parent scopes. And if it cannot find the definition of Y, it's going to not print it. So in this case, we have got some variables here. And it says X is defined, but Y is not defined. So to prove this works, I'm now going to define Y, and it's going to say Y is defined. This is for a future feature which I've not technically implemented yet, which is where you can define constants on the command line interface. So this may be useful if you want to be able to set certain compiler flags, like you want to have your own debug mode or such. This is kind of where it's going to come from. So that's good. So there is also the union type now. I'm skipping on to going through this because there is quite a lot to get through. And if you've got any questions, please feel free to ask, or you can wait till the end if you want. Either way, I'm not actually that bothered. So there's the union type. Now, this is actually, I've already talked about this before, and a union type is a tagged union which can take on multiple different values, so different types. For instance, this is a very basic example where a union can be an int or a bool, or it can be nil, so it can be none of these values. Yeah? So if I have a union here, assign it to be with the value 137, the 137 says, okay, it's going to be an int. It's assigned, so now it becomes an int. I'm going to check with this is called a type assertion. We get the value from it and checking it's okay. And if this type assertion is okay, we can go into it. Sorry, someone's asking, no, we cannot define names on the command line yet. This is going to be a new feature I'll just add, probably still within this 0.9, but I just haven't implemented it yet. That's all. Okay, so this is going to print over here. Okay, and if we go up to the top again, 1, 2, 3, 7, there you go, union type, it works. We're now going to assign value with true, which is a Boolean. And if we print that, we don't even have to go through this loop. It says true. If we then assign nil to this value, we're going to go on this switch statement here, which says for the v in the value, so this is the element, the v, we're going to switch on the case which has that value. So it could be an int or a bool or none of those values. In this case, it is nil. So it's just the nil value. It's quite useful to have. As you may notice, there's a duality between this and the any type. The any type has a pointer to the data, but allows for any type, so it's quite open about whatever it wants. While the union type is a kind of like a binary blob that stores the data itself and only allows certain types, so it's closed. So they are kind of like yin and yang in this case. And I can write the exact same code as before, and it'll work just the same. The only difference here is the memory layout and where the memory is allocated. In this thing, it's in the binary blob itself. In this, it's a reference to a value stored on the stack. And this is very useful for certain things later I shall show. So a more realistic example of such a thing would be here. Now, again, I'm going to just read out the comments here, but you can read them anyway. It says, for the above examples, you may have not seen a particular use for this. However, my main use for these is quite simple. I'm using this to use it for hierarchical types, and I may prefer subtyping in one case, or I may actually prefer using unions, tags, and I want to be able to change between the two of them quite quickly because they have got different memory layout strategies and the different work. So this case here is a subtyping strategy. So I have a base entity type which has some information in it. And note it has this derived any in there. It's very useful. Then we have some derived entity types like a frog and a monster, and they're both using an entity. Remember this using feature, very useful to have with polymorphism. I can now allocate a new entity. I'll explain the new syntax in a bit, but don't worry, this just means you pass in a type and it will allocate the new thing here. So I'm going to say a new entity of a monster and do the entity, and then I'm going to switch on it. So get the E in the entity derived and check the cases. So frog and monster. In this case is a monster, and it doesn't print anything, but just to prove that it can be, we've got the monster here, but yeah, it hasn't got anything set. So if we're going to say it's not a robot, it's going to go print robotic. And there you go, it says print robotic. So it did get to this stage here. I'm a monster. It says that. I'm a monster. There we go. Absolutely lovely. Now notice we can achieve the exact same thing with a union, but the difference is the memory layout. Remember, an any stores a pointer to the data, while a union it has a blob of this data. And this can, the union restricts what we want, while an any can be anything. In this case, we've now got derived again, and we're using frogs. In this case, they're still doing polymorphism, but they're using a pointer to the entity. And this is a blob to the data rather than a pointer. So you can see they've kind of been flipped, but the actual code is identical in this case. So how you use it is the same. Nothing's changed. This is quite useful to have. The only thing here is we're setting it directly and we're having to reference where the entity was. Okay, it's very useful to have. Again, they both have advantages and disadvantages. You may be thinking, okay, I want to use a pointer to something, but I want to restrict the amount of different types I can use in it. Well, you can do the exact same thing here. You just have to specify their pointers to it, and that will change the memory layout. And you can still do the same thing. Like so, magic. So if you want to read any more of this, please read the comments. I have got some nice little things in the demonstration. Again, you can download this in the latest release, and this will be on the here on the GitHub in the releases, and you can download the latest release, and it'll have in the examples there. Okay, hopefully everyone's following along. We're going to the parametric polymorphism now, which has mildly changed syntax, and I'll explain why. So hopefully most people understand that this $sign here is we're going to allows for polymorphic type. So we have print value. It takes a value and this $t, which will be determined implicitly by the parameters it's given. So for instance, we have v1, v2, v3, and v4. v1's an int, f32, and f64, and a string. And they all do this, different things. So what I'm going to do here is demo again, and just to isolate this, which might be a lot easier for people to understand. There we go, it's all isolated. So print value 1, it will take an int, and it's actually printing an int, and it knows the type because it's printing the value of this type. Yeah? In this case, it knows an f32, this was an f64, and the other one was a string. That's good. So this is already know. So it determines what the type of t is from this. You can also use this on multiple of the different parameters. So this is p and q, and these operations will work here. So you can do an add of these things here, and it will determine that this should be an int. And in this case, it has figured it out to be an int, because the default value of this literal is an int. But these in this case are floats, but the default value for a float is an f64. So it's figured that out as well. Now, note where the $sign is defined. If the $sign is on the right, on this type thing, it means that the type itself is polymorphic. If the $sign is on the actual name, it means it's a polymorphic name, which means that this parameter will be a constant. So this is quite a new feature. Slightly new feature and slightly designed. So this equivalent function here used to be written as the following. But can you understand why I changed this? I'll explain why. The first thing is here, as I said, look, this is a constant parameter. Yeah? and it's going to be, that constant parameter is going to be defined as t. And we're going to say this, the value type of this parameter is a type. And in this case, it's now called type ID, which is a keyword. Previously, we just had, okay, this is a type that you're passing along, and it's going to be a type, and it's going to be called t. There was no indication that this was a constant parameter, and it also meant that the name, the key identifier to type had to be a keyword. So that meant that people couldn't use this as an identifier or anything. And it's a little bit annoying, but I found a way around it. So the way I could do this was having the type ID be a new type. So you'd have a type ID of any type in the actual language, and it would just be like an ID that gets passed around. But if you made it constant, you could pass the actual type of it passed. Hopefully people are following me. So if I was using this procedure, here's a pointer, and I'd pass an int. And this is, just to be explicit, this is a pointer to an int I'm passing. So this is a constant parameter that I'm passing. Okay, hopefully people are following along. So $t is both for implicit and explicit, so there's a beautiful symmetry to be used, but it's depending on if it's on the name of the value or on the type itself. So in this case here, we've got a copying of a slice, it's on the type, so the element is polymorphic. In this case, we can also add a multiple of the dollars to different types, and it would still work here. So like the double params, it'll figure itself out. Here is now we're going to get a little bit more complicated. So this is a little bit more complicated in that we are now doing polymorphic types and also talking about type specialization. So someone's got a good question. Can you do this for other types of constants as well? And that is, yes, that is absolutely correct. I'm just checking. Yes, I'm going to talk about it in a few minutes. So you're jumping the gun there. I'll explain, I'll show a good example. So let's talk about polymorphic types. So structs and unions now allow you to have parameters. In this case, these parameters are just type IDs. Theoretically, I could put the dollar signs on here, but because every single parameter to a struct must be constant, these dollar signs are actually redundant. And it says, and I'm sending this as an error, polymorphic names are not needed for struct parameters. So, okay, we don't have to have them. Even though theoretically that should be allowed, I'm just not allowing them because they are redundant. So here we go, is we're just going to make our own little, really bad, but it should work, little hash table. So this is a table slot, an entry in a slot, which say if it's occupied, its hash value, if it's key and its value. Then we have a table which will store the count, its allocator, and then the slots in that table. And these will just pass along the key and the value. Okay. That's very useful to have. So the next thing I need to explain is type specialization. So remember this $t type ID said, okay, we can pass in a parameter of a type. But if we have a slash after this type ID, it means, okay, we want this type to be specifically a specialization, in this case, of a slice to some element which can be determined at compile time. And this will allocate us polymorphic procedure. So we use this make slice. It could be used such as this. So I'd go pass me a slice to an int of size 123 or size 16. And in that case, it'll work absolutely fine. And this is how make is implemented for the other things as well anyway. Another way of doing this is not just be a specific type, but is if the type itself is polymorphic or something else. In this case, you can do /t. So on the actual type itself. So this is I'm going to be very clear. This $t is the actual type, and the $t has to be a specialization of table, which is this polymorphic struct. Okay. Then this what we pass to it must be a pointer to this polymorphic thing. Okay, hopefully that's making sense. And this is just a function to explain how this thing works. You can use it again here where you've got this /table, and that will work like so. Now, sometimes you may prefer to actually be a little bit more explicit about it. So in this case, I'm putting a slot in the table, this entry. You could say write the table and then put the parameters itself on the value and write the word key and value in there. And that would work as well. And that's another way. And this is identical to if I wrote the above thing here. So this $t/table, and then I went t.key, t.value. These two are equivalent and they will work just the same. But sometimes you want to be explicit that these are the parameters you're passing. Sometimes you don't need to be. This is kind of an aesthetic thing as well. So there. Now sometimes I would usually prefer the top one. The main reason why I prefer this top one here is because I can always refer back to the original type rather than the elements in it, while this one prefers the elements. That's my personal preference, at least. Again, I'm using this here as another example, and there as well. Let's get hash, and this table thing works as well. It's saying it's found the values. Yep, good. Now, again, as I said, this thing also works with unions. So I could have a parametric polymorphic union. Now, that's a really long thing to say. I usually say parapoly for short. It's much easier to say. So in this case, I've got a parametric union, which takes in a type, a name, we're going to call it T, and then its elements in this union are going to be T and error. Okay, so error in this case is an enum with certain values, and T is defined by the user. So I can say this para union is an int, and then it will take this value. So if I went, what is the type of R, and then give me the type ID, which is this little ID that you pass around. When I pass this to print line, it says this is a para union of int. It knew what it was. It was great. Now, if I print R, it should be nil, because again, it's not been assigned any value yet. Now, if I signed it 1, 2, 3, it should be printing out 1, 2, 3. Now, if I sound it an error value, it should be printing out foo, 0. If you are coming from other languages, you may think, okay, this para union looks very, very similar to something like a result value type. So you could have a result type or an error type, or it could be something very similar, some of the enumeration of things. Now, personally, I do not use it in that particular case. I do not really like return value types, because in Odin there are multiple return values, and I much prefer that approach to error handling than the have only one return value, but have it be a multiple different types of types, if that makes any sense. So, okay. So now let's get back to the question that someone asked previously, which is the polymorphic names. So this is actually a simple function which is trying to explain loads of things that are going on. So this thing first here is the value n is polymorphic. So the name of it is, okay, the parameter passing thing has to be constant. But we don't know its type, so we're going to determine its type parametrically as well. Yeah, so it is going to be parametric, and then we're passing a constant parameter which has to be a type. Okay? So this is this foo. It's going to say generating array of type, whatever that type is, from the value v and of type v. Okay? Let's go there. So I'm just having a new type, let's call this t, which is int, and it's going to be an array that's going to be of length 4, and this is an integer here, and let's pass it to t. And if you read it here, this is generating an array of type 4 int, and it's going to have a value of 4 of type int. And it knew what the type was passed in. We could be explicit about what the type of that constant parameter should be. Where is this? Where's going wrong? Undeclared I, so it doesn't even know what I is yet. So let's just say type ID of I32. And the result here is of type t, which is int. So let's just do a cast. Yeah, so I was being very careful. So now it's doing that, and the parameter was of 4, but it was of I32. It could be of 23, and it was on I32. We could do that again. and it would still work. So it works quite well. Change that to a Boolean. No, let's go for an F32, and it would figure this out. So it's a very useful thing to have. Okay, good. So that's the parametric polymorphism stuff. We can go through this little threading example. This is just to show that threads exist. But that is not the thing I actually want to show. It's not the thread. I want to show a new thing in the actual language of Odin, which is the Intrinsic Package. So if we go, let's go to Atomic, which is in the sync package. I am now importing this intrinsics. Now intrinsics is a reserved package name, which has to be used by the compiler, because when you import intrinsics, there are intrinsics procedures which you can use. So in this case, the ones I've implemented are for atomics. So I made a nice little atomics library which you can use, but you can always call these directly. So for instance, this is an atomic fence which is released, or an atomic fence acquire. So I'm using a different, I'm using a very strict ordering model for the atomics. They're not just simple load and unload, which is quite useful. For instance, this is an atomic store, which could be relaxed or released or just a general, by default, sequentially consistent. And these are called from here. And this little sync library for the atomics is actually just a, what's the best way of putting it? This is a nice little wrapper, so you've got some more Odin features, but also you can have the explicit enum for the ordering in there when you use it. So this is a very nice little thing to have. But Odin now has intrinsics. So eventually, as the language progresses, I'll be adding new kind of procedures that will be intrinsic to things. So you may be able to, instead of going into assembly, which I'm planning to add assembly as part of the build process, so you can have your own custom assembly. Not sure if it should be inline or part as another file in the package yet, but that's something I can decide. You may want to use intrinsics instead, and that's an option. So that's one good thing to have. So let's go off the threading example and go to array programming now. Now array programming is something I've already demonstrated, but I'm just going to go quickly over it again. Odin supports array programming, which is, let's say I've got an array of, it's an array 3 of F32. I can do element-wise operations on them. So whatever the operations of each element could do, I could do before. So for instance, here's an array here and another array, multiply them together, which gives me another array of C. I can add them together, element-wise gives me D, then do this operation like it's just some basic normal maths, and then gives me a new value out, which is what it prints out here. So look at how kind of magical that works. Okay. Is everyone already following along? Good. There's other operations which already existed before, which is swizzle. Swizzle worked on any array type, which you just say, okay, you pass the array in, you swap the elements around, and it will give you the new thing. So swizzle was already here, it's been for a very long time. But yeah, and again, printf works on arrays. Yeah, because it doesn't care. This is one cool thing about Odin, is it knows this is an array, or it knows it's a slice, but it only only cares about what the elements you pass to it. So it works with arrays in that case. So beautiful thing. We can go to another thing here. So this is, I'm going to make a distinct array. Okay, so call this vector3. This is distinct from the actual vector3 type, but you may want to use this. Now, one of the cool things I added, if you didn't know this already, is that for arrays of length 4, 3, 2, or 1, you can access them as if they were like a built-in vector type. So .x, .y, and .z, and also if this was a vector 4, there would be a .w. Yeah? So you could treat them as that. So it's a very useful thing to have, because sometimes you want to do that. So in this case, we do all these operations, and D, and then again it becomes 22. Using that little feature beforehand, we could do the cross product here. So we could do all these swizzle operations, and then get them together, do the cross product. And then it could also just get some blah function, which just gets the elements. So it's a very nice little thing to have. Array programming was kind of an idea that I kind of borrowed from Ada, but it also solves a lot of the issues I had where one of the reasons I wanted to operate array overloading in the language was mainly for I found to be just mathematical types. And if I added this kind of feature, it kind of solved most of my personal wants. Not all of them, but more than enough that I can just accept as a compromise. It's very useful to have. Another feature here is I'm going to talk about is named procedure return parameters, which is quite simple to explain. Here's a normal procedure which takes nothing and returns an int. Okay, done. I can also define, someone's asked questions, so for arrays A and B, what does A times B mean? Well, just to be very clear again, this means you're going to multiply two arrays that are element-wise together, so the elements themselves get multiplied and produces an array of the same length. So this is a, I'm going to say English way, Hadamard product, not Hadamard product. It's a Hadamard product rather than a dot product or a cross product. Okay, does that make sense? Yeah. In mathematical notation, you do the big circle as the multiplication sign, but yeah, whatever. Okay, hope that's answered your question. Back onto name parameters. So one thing I can do is I can name the parameters here of a return value. This is very good for documentation without writing a comment. So this could say, okay, this is parameters, whatever it's named is, because you could have multiple of the same type. Now, one of the things here is it looks like it's a variable declaration or like a parameter declaration. So why can't I assign to it? Well, that's the cool thing about it. You can, because it just acts like it's a variable within this scope. And then one of the things, because it's named, I can just return, because these will just have the default values already. So that's pretty interesting to have. So this is very useful. So for instance, this could have two default values for A and B as an int. We could assign themselves. And again, because they're just like variables, we could just return them in the opposite order if we wanted. So that's quite a nice way of putting it. And you can just print these out and you can see what's happening. So like this, foo0 returns 1, 2, 3. Yep. Foo1 returns 1, 2, 3 as well. But foo2, remember, we swap them around, would be 5, 6, 7, 3, 2, 1. Absolutely beautiful. So that's named parameters with Georgian. The next thing is using enum. Now, in a previous version, this wasn't looking exactly the same as this, but I changed it because I thought this is the most way of making it consistent. So without using the using here, this code would look something like this. So you'd have an enum declaration here, which has got A, B, and C in it. So you go foo.a, foo.b, foo.c, and print them out and just use them normally. Okay? Good. Now, we can get rid of this, and we could say using foo. Yeah? And makes it more like C-like. Now, my question was, okay, why not just allow people to just put using on the type declaration itself? So I allowed that. Absolutely done. And that's just useful. So it's a very useful way of doing it. So someone's saying here you can't really do operations on it, which is not necessarily true. I think you technically cannot do that now. Yeah, so this is not this is an old comment, but I'm going to just delete it anyway. The reason why was I was experimenting with different enum operations, so I wasn't sure which was the best way of handling things. But yeah, it was kind of that. Okay. Good. So next we're going on to explicit procedure overloading. So Odin has explicit procedure overloading, not implicit. So something like C++ has, if you have two procedures functions defined with the same name, then they'll be overloaded. In Odin, I did not want to do this. This is again related to the package problem I had, where I was explaining at the start, where I wanted deterministic names for declarations. That's deterministic if they're not polymorphic, of course, but deterministic with their names. So what you see is what you get. The issue here was that, okay, if I do not want to, I want it to be deterministic, how do I do overloading? Because sometimes overloading is very useful to have, but it also means there's also some other issues. So one of the issues is what scope is it being overloaded in? And if it's being overloaded in one scope, that means if you overload it in like a child scope, it overrides everything else. So it gets a bit confusing. So one way around this problem is to be explicit about what you're overloading and give it a specific name. So let's have, we have three procedures here. We have add ints, add floats, and add numbers. So this add ints takes two parameters which are int, add floats takes two parameters which is a float, and add numbers takes an int, an f32, and a u8. Yeah? So that's kind of a nice little thing here. So now what we're going to do is the overloaded procedure group. So the syntax for this is not finalized, but it's pretty much something similar to this. So we're saying it's a proc group of containing add ints, add floats, and add numbers. I'm going to define it with the name add. So in this case, we're going to do add, which in this case will be, we're going to pass it int. We'll take this one, it will know which one it is. And you can see it says add int 3. Next one will be float, and this one will be just the numbers. It will figure that out. Now from here, it's going to figure out all the other stuff. So in this case, it's going to do I've defined some clever rules to determine which things it should be. So by default, these literals are untyped integers. That will be their type of them. So the untyped ints coerce tighter to an int than they do to an f32, because they're integers, not floating points. Now these with the dot zeros on the end, even though they are technically representable by an integer, they coerce closer to a floating point number because they've got that point in them. Okay, does that make sense? So that's why it gets chosen to be the float. For the three parameters, well, it figures out that, okay, there's three parameters being passed in. It's clearly none of those two, so it must be the third one. So it's going to use that. Now, to note this here, there's some ambiguous answers. For instance, if I said, okay, there is one parameter which is like an untyped float and one's an untyped integer, it says, okay, which one do you want to call? It's an ambiguous procedure call, group call, add, that match with the given argument. So it's being given an untyped float and untyped int. So which one did you mean? Because I have no idea. And again, it's the same if we do the opposite way around. It has no idea which one you meant to choose. So that's explicit procedure overloading. Next is a nice little feature that I like to have, which is called complete switch. So you may have a switch statement, but you want to make sure that all of the cases are handled. So it's a complete set of the cases as the name thing. So all you just do is put the compiler directive complete in front of the switch statement, and it will check to see that you've done everything. So if I got rid of, for instance, let's do this enum here, and I got rid of the D and default case. It says unhandled switch case D. And it says, oh, okay, let's add D in there, and it will still work. Now, if I put just a default case in there, it will still moan at me, because it will say, look, you haven't handled the explicit case of D, even if you want it to be the default. So you think, okay, let's handle that in. This also works for union types, where unions have specific types in them. For instance, you want to handle all the different cases of the type. So let's say we got rid of the int. It says unhandled switch case int. Oh, I forgot to do that. Great. Let's do that. This is a very useful thing to have if you're doing like a parser or a generator of some sort, where you want to make sure you've handled every single kind of like a union or an enumeration. It's very useful to have. So that's just a complete switch. Very simple, but very handy for picking up tests. Now the next one is going to surprise a lot of people here, but let's understand it first. So this is the C-string type. Now, in Odin, there is the string type. The string type is pretty much contains a pointer to the data and a length, which is an integer. But because Odin wants to kind of talk to C a lot, it gets kind of a pain when you're trying to convert an Odin string to a C string. Now C strings are just a pointer, and they point to bytes, and they'll be null terminated. The issue here is that means you'll need either some temporary allocation, or you need to ensure that the person who's passed in the string has null terminated their string, which is not a guarantee. So one of the things when I was doing this bindings was like, okay, how the hell am I going to do this? And I thought, okay, let's just handle a cstring in there. So cstring is now a built-in type into Odin. This is again a compromise, but it makes a lot of sense. So again, with the constants here, the constant system doesn't really care. This is just a string value with a type cstring. It will just handle it correctly. And as you can see here, it's printing everything out correctly. So it prints out the strings x, y, and z. So x in this case is a cstring. Y in this case is just a string. And z is a string, normal string, but it's the conversion of x. Now, note this cast here is from a cstring to a string. This will be again, big O n conversion because it has to find, if this is runtime, it has to find the null pointer, which will determine its length, and then it will store it in the string. So this is a slow operation to do at runtime, just to be clear, but it's, again, sometimes very useful to have. In this case is with the leng as well. If you've got a length of a C string, again, important note, the length of a C string is going to be in n length, depending, it's going to be as fast as that. Compared to a string, when you do the length of a string, that's going to be constant time because it's just looking up the value that's stored in there. Okay, this is very useful to have. If I go to, like, for instance, the Windows library, I use this C string in quite a lot of places. Like, for instance, here it's to note C string, or in these structs them, or there's going to be a C string. Oh, that's a bit dodginess there. Oops, that is not a very good way of rendering it, but whatever. In some of the procedures, I'll have like a C string as well, so it's very useful to have. Now, you may be asking me, why was this even really an issue? And the main reason for this is C has 3 different pointer to bytes. So if you've never actually thought this through before, in C, we'll just do an example here, you can have a unsigned char pointer. You can have a signed char pointer, and you can have a char pointer. These are all pointers to bytes, but they're all different. So this is an unsigned char. So if I did this in Odin, this would be a pointer to UE8. If I did this again in Odin, it'd be a pointer to I8. Now the next thing is a char. So a char is actually a character type. There is no equivalent in Odin, nor should there be. So the equivalent in Odin to this is now a C string, because in C, this C star is specifically being a string. So I was thinking, how do I represent this concept to be a string? And the only way I could come up with is have that be a specific type in itself. So that was my solution to that problem. Hopefully that's cleared up some stuff. I've been talking for an hour so far, and there's a lot to get through. And I've still got through. People asking what editor this is Sublime Text. This is what I use quite often. So there you go. So let's go to another lovely attribute feature, which is the deprecated attribute. So sometimes when you're designing a library, you want to deprecate, say, something like a procedure call and say, like, just don't use this anymore. So you have 2 versions of a procedure, like version 1 and version 2. So if I called version 1, I'll have a warning from the compiler saying it is foo1 is deprecated, use foo2 instead. Now the deprecation message is optional. So if I didn't have that, it would just, it's not optional, but it's, actually that's a lie, it shouldn't be optional. No, it isn't optional, it was a design choice, that was a design choice. I wanted a deprecation message there saying, look, you need to give some information about why it was deprecated and what to use instead. That's why. So if I got rid of this, and let's say I used version 2 instead, okay, it's not going to yell at me. Great, that's just deprecation attribute. That's pretty useful. Next is the bit set type. Now this is one of my new favorite features. This is actually, even though it's how simple it is so useful. So the bit set type is, as the name suggests, it's a set of bits. So let's say you have an enum here, which contains the days of the week. Sunday, Monday, happy days. Tuesday, Wednesday, happy days. Thursday, Friday, happy days. Okay, I'm not singing the bloody Happy Days theme tune. Oh God, even though probably at the moment I do look like Ron Howard with more hair. Yeah, that's probably a bad sight to think about. Actually, no, I don't look like Lauren Howard except the ginger hair. That's about it. But yes, so let's carry on here. Now, I'm now going to create a bit set of this enum. So each of these values can occupy a bit in the bit set. And this is a very useful way. So most people would use do this with just like values and enums and just do the values themselves. But it's sometimes much easier to think of them as many of them as just as a set. So for instance, I'm going to have a set of days. These days are now going to have the members Sunday and Monday in them. It's just the beginning of that tune. I'm now going to define an enum value here, which is X, which is just Tuesday. So it's just the enum. It's not even the set now. I'm going to have another set called E, which is going to be D, which is the original set. This set here was Sunday and Monday. And then I'm going to put an OR with it, an OR with the weekdays, weekend. So now this is going to contain Sunday, Monday, and Saturday. Yeah? I'm then also going to OR in Monday, but that was already there anyway, but just state it. So when I print this, D, which was just Sunday and Monday, will print out as Sunday and Monday. And then E will be Sunday, Monday, and Saturday. Magic! How magic is that? Now another thing, a little operator I added in, which is the in operator. So this is only allowed to be used on a map type or a bit set. And it's just to check, does this value exist within this thing? So does Saturday exist within the set of E? And if it's okay, it'll print out true. That's great. I can also use this in an if statement, like if Saturday is in E, print out Saturday in E, and Saturday is in those days. This also works for compile time constant evaluation. So notice this weekend was defined as a constant, so I can check this and still define it as a constant. Notice how useful this is already going to be. This is already more useful than the way you would do this in C or C++, where you'd have you define all the offsets of the bits themselves. But in this case, this is just the bit sets. I'll be honest with you, I nicked this idea from Pascal, but it is one of the most useful things I've found, and it's like, okay, I really want this. It's so useful. Now, let's go to another thing. So instead of just having an enum we could pass in there, we can also pass a range. So I can have a bit set of a range from the letter A to Z. Now, A to Z, that is 26 different characters, yeah? So that means I need 26 different bits to represent that bit set. So if I do the size of X, it will notice look, this is true. This size of this bit set is a U32. I can make this a compile time constant, actually, it will just work as well. So it is because the next integer type, because that's how bit sets are stored as integers, is after 26 bits, is going to be a 32-bit integer. I can be explicit here. For instance, I could say that instead of having an array of these characters, a set of numbers. So this will require from 0 to 8, which is 9 bits. So I can say, okay, that requires 9 bits, which needs to be a U16. Now I can be explicit by that by having a semicolon after the set and then specifying what the underlying integer should be. So that should work. So if I print this out, it actually prints out exactly as it should be. And there's the bit set of that type. It's printed out correctly. It's going to be the type as that. It's print that out correctly. It's great. Good. Now, onto one of the fun things. So one of some built-in procedures I've added, such as I've called incl, which is you include a value into that set. So you can just take the reference to that and add the value in. That'll work. And that's going to assert that f is in X. I can also exclude a value from there, like this as well. So this is actually equivalent to if I did this. And that is actually equivalent to if I did that. But can you notice that this may be a little bit more explicit than writing that, and so that'll be a bit more explicit than writing, actually that's not correct, that. Because I'm excluding, doing an and not on this set. So that function call may be more clear to some people. It also means one of the cool things I added in here is I also made it so you could add as many as you want. And that would work as well. And that's sometimes a bit clearer. You want to include an element rather than ORing with another set. This exclusion, we'll get it. It says excludes it from the set, so it's going to be not, f is not in X. So another little value I wanted to write here was you can also just do the OR of this little grouping set here. And then do it here. So someone's asking, are you talking about bit flags right now? So yes, these are bit flags, but they're a much nicer way of doing it. This is more Pascal approach to it rather than the C approach. This probably is very foreign to a lot of people, but it should make a lot of sense. This is more like a mathematical set. It's very, and again, it's more useful. So the next feature makes it very more like a mathematical set as well. So let's say I've got a set of letters. So this is a type of letters. Goes A to Z, I can allow, and I've got three different variables. I've got the variables A, which contains A and B, the variable B, which is A, B, C, D, and F, and variable C, which is A and B. I've got different assertions here. So A, I can assert so A is, this says less than or equal to B. That does make sense when you think about sets, like less than or equal to B? No. But this is kind of actually saying, no, this is a subset of B, right? And you could say the opposite way around, so B is a superset of A. This makes more sense if you think of it like as a, does this contain the other thing? Yeah, good. Now you could get rid of the equals, and this means, okay, is this a strict subset of B? Now a strict subset means it can be a subset, but it cannot be itself. That's all that means is, yeah? So like, same with numbers, in fact, like 1 is less than or equal to 2, but also 1 is also strictly less than 2, yeah? That's what all that means. And now this, the opposite way around, is also a strict superset of A. Okay? So yeah, they may seem a little bit unusual to people, but this is actually just because it's a different family of languages. This actually makes it feel more like mathematics, really, rather than it is. You don't have to worry about the existence like other things. Like this is just explaining that there. So just to explain how people do it in, let's say we're doing C++, to do the exact same thing here, yeah? You could call this a day flag. You'd have an enum, you'd have Sunday, and then you'd do that. You then have Monday, you do 1. You'd have Tuesday, you'd have 2. You can see where I'm going with this, right? Wednesday, 3, Thursday or Thursday. Fine. Wednesday is Woden's Day or Odin's Day. Right, it's not Odin's Day, it's actually Saturday at the moment. Friday, Freya's Day. And then Saturday, which is Saturn's Day. So you can do that. And then what you would do is you've got now the day flag set. You would do the exact same thing here. You'd go D and you'd do day flag Sunday dash day flag Monday, and you'd do it like that. But the thing is, you kind of done this, and you have to do the low-level operations. It doesn't naturally flow like you would actually do flags like this, which makes sense. So someone's asking, can you enumerate days for like days in a weekend? I cannot remember, actually. I don't remember if I allowed enumerations. I think I did. Let me just check. Yeah, let's. How do I do that? I cannot remember if I've even had implemented half the features I did, to be honest with you. It's one of those things. Let me just check. For E in A, from print line E. No, I have not allowed that. That might be an option to implement, but I haven't implemented it. So I apologize for that. So let's go for the last feature, which is more of the, of this demo at least, more of the just very low level geeky stuff. So this is called a diverging procedures. Okay, this is going to be confusing to a lot of people, but all this means is if I write arrow and then exclamation mark, this procedure may never return. You cannot return from it. You can't say return. it will say divergent procedures cannot return. This is very useful to note to the compiler to do certain operations. Like for instance, you may have an assert or a panic, and these should never return in themselves. All they do is they should just panic, and that's kind of a note to the compiler, hey, this thing won't return. Okay, know that. So that's just some geekiness there. Okay, for the average person, they're going to not even know what's going to be, why they need that. But okay, so that's kind of some of the stuff. But as this release actually says, I've actually not covered everything yet. Okay, so some of the stuff on this list you may be able to note. So someone's asking, couldn't you just have return value? So they aren't actually the same. So I'm going to have bar, right? Proc, and then have nothing return. Yeah? So if I said return true and then return there, you're earlier returning. Yeah? But I'm returning. That's slightly, in it when you're actually doing a procedure, if you had only one out exit for a procedure, you'd have to jump to that exit and then return there. That's how it would work. Yeah? Okay, so let's go back there. So let's talk about some of the sexy features in this language. Oh yeah. So one of them is the type ID, which we've seen already. So type ID is you can get the type ID of any particular type. So let's say I want the type ID of, and I'll just write it a bit more explicit, of an int. So this will be a unique ID for the integer, which I'll print out, and if I pass it to print line, it knows, okay, this is a type ID, I can pass an int, and it'll print the int. So this is very useful when you want to store a particular type and you'll be able to do comparisons later on. So it's kind of a bit more useful. You can also get the type information for that thing as well. So I can go type info of that ID, which is actually a pointer to the type information, and it will still work as well. So the type information is all the more information inside of it. So that is what type ID is. Note of the note here is I removed the keyword type. So type, you can now just use it as a standard identifier. So that's very useful to have. The other thing here is also the opaque type. Now this is a bit confusing to most people, so I probably won't demonstrate it. This is more of a used for, okay, you can say it, it's probably used to explain. So let's say I have my handle. So this is a handle type, yeah? Let's say I wanted it to be an integer size, or let's say U32, yeah? Yeah, so I'll get onto that in a minute, don't worry. So we'll say my handle. Now the problem with my handle, in your, we'll say it was your library or something, someone could have this and they could just write their own in there. And that might be fine, that's fine. But they could then do this on the end. Now you notice this is a handle. Do you want people to be able to do basic operations on this handle, other than say comparisons? The answer is no, that doesn't make any sense. So the way you could do this is why I added it, was the opaque type. What this now means is it's saying you cannot convert a U32 to my handle, because the U32 must be of the underlying type. Yeah. And then it says, oh, actually that was right. Whoops, Daisy. Oh, we'll be back. Oh, for Pete's sake. So I'm going to do that. I am now going to close Sublime Text. There's a bug in Sublime Text at the moment. And then reload it. There again. Python does not like me. And then it's complaining here, you cannot convert 123 to a handle. So just say, okay, we knew that. X plus 123. Well, it doesn't work. So we've now disabled its actual ability to do it. Now, yes, someone's saying you could do this bit hacking, and that's correct, you could. But it's more of a, yes, you shouldn't be doing this, so I'm not going to allow you to accidentally do it. And it's really easy to do. So that's more, it's saying, but you're allowed, you could have another handle here. Yeah? You're still allowed, you can do the comparison. So comparisons are allowed under there. So that is still allowed. So that's kind of what we use the opaque thing is for a bad thing. This opaque thing doesn't have to be with a thing. It could be a structure under there, whatever. It's just a blob of data that's opaque to the user so they cannot know what it is. Okay. Let's go back to the releases on here. What else is on here that I haven't talked about? Autocast, which is another unary operator. So autocast is something that's a little bit crazy, but it's quite useful in some particular cases. So let's say I've got an int, 1, 2, 3. And then I've got a float here, yeah? What I would normally do to assign to this float is I'd have to convert this x to the type of the actual parameter, okay? Someone's asking, you cannot access the members on struct. That's correct. That would be what it is. Opaque, it literally just makes an opaque binary blob of that data that you can do comparisons on if the underlying type supported comparisons. Hopefully that makes sense. Okay. It's kind of approached to make it more sense with the opaque. It's kind of like what C++ does with private, but literally makes them properly private. Someone's asking, is when like C's preprocessor if? Yes, but it's not at a preprocessor level. It is done actually at the compile time level. So there is no preprocessor in Odin. You could always use C preprocessor if you actually really wanted to. There's nothing stopping you. But I don't really see why you'd want to. It's a bit crazy in my opinion. So let's go back to this auto cast thing. So when you were assigning things, you'd have to be explicit about the casting. So if you got rid of it, it'll say, look, oh, you cannot assign x of type int to an F32 in assignment. So one thing you can do sometimes is just write autocast, and it will just do it for you. And it will just work magically. And this may seem that this is very dangerous, but there's a thing. Luckily, the name of autocast is quite long and long to type, so it's not necessarily a bad thing to have, and also it's very easy to grep, so you can find it in your file and stuff. You can also add this to procedure like parameters. So, for instance, you could have, let's say you got foo proc autocast x int. Funct print line x like this, and I'm just going to do 1 to 3. I'm going to again pass y in, but notice y is of type F32. It then is going to autocast here, so we could get rid of this autocast, put the autocast in that parameter, and it would work. Or we could say everything to that would be here. Now, personally, I do not like this. This is I've added this as like it's useful in some particular cases. But it's also a, don't do this if you can. Please don't do this. This is just like, this is for like if you need to do a hack and you're trying to get stuff working quickly. Do not do this in a real library, please. Okay. Good. Now, is there anything else I need to explain? What is something else that I could talk about? Yes, so some of the features with regards to the context. Now, this is going to be difficult to explain to people who have never used Odin before, and looking at the time, I've already been speaking for nearly 90 minutes. So I'm going to talk about briefly over what the context actually is. Okay. Good. So the context. Yes, someone's asking in the chat. They don't think Odin is going to be the correct language for them. That's absolutely fine. Odin is meant for a particular style of people and what they like. Stating that you need object-oriented programming. That's fine. So someone's actually checked. Why don't you just check out Go? I honestly highly recommend Go if you really want the object style of things. So if you really, really want object-oriented stuff, then you'll like Go. Now, you're saying you don't like Golang. May I ask why? Is it because Go isn't traditional object-oriented language because it doesn't have strict hierarchies? and it has rather the interfaces method, where if you define the methods for that interface, that will reference that interface itself. Or it's one of those where if for object-oriented languages, I really like Go, but if you're like more traditional, if you like the hierarchical Java-like, C++-like object-oriented languages, then you're probably not going to like Go. It's one of those, if it makes any sense. So I'm near. Oh yes, there's one other feature I forgot to talk about, which is the foreign import groupings. So if I went back to my little tool here, and I'm going to go to glfw, is it? Okay, so it's not that one there, it's stb, isn't it? So Odin. So when I was designing this, sometimes when I'm importing a library, which if you know already, you can import libraries and reference by a name. So when you're doing a foreign block, it's referenced by the name. It's very useful, yeah? So sometimes you want to be able to import multiple libraries under a certain name, because we could have multiple .libs or .dlls or whatever that need to be required to be together. So I wanted something to say, just pretend this was the case. Yeah, you could have this, and they're in parts, and sometimes you really need to do that. In the previous Odin, you couldn't do this, but now you can by collecting them in a braces. If you only need one, you don't need the braces. Okay, great. Sorry, going back, yeah, that's the other feature I wanted to talk about. It's just something very simple, but very, very useful in certain cases. So going back to this person saying they talk about don't like Go, they say I grew up with a language that's based on inheritance, so there's no inheritance in Golang, that's why I don't like it. I think this is also one of the problems where I am not used to it, therefore I don't like it, is not usually a valid criticism. It is sometimes a valid criticism. I should be honest with you. If you're not used to something and you're trying to use it straight away, you cannot use it. It's not very good for you. You're not very productive. But if it's the entire argument is just because I'm not used to it, I don't like it, is your full criticism, that's not particularly a very good criticism of the language entirety. I think you'll be surprised you will not by how little you'll need inheritance in Go. I'm not saying you don't need inheritance for certain things. You can actually have certain type of inheritance in Go. It's just embedding rather than traditional inheritance. But you'll be surprised at how little you'll need it. What is the other feature? And oh yes, there's one other feature I haven't explained, which I'll just quickly go over. So instead of the context, which I'll probably have to do another video on to explain the entirety of how context works, I want to explain the inline and no inline on procedure calls. So let's say I have this procedure, right? Like this, it has a procedure that it orders this foo. So I'm just going to call this foo and print it, yeah? You may want to tell the compiler saying, look, this procedure, I know I want this to be inlined always. This is not a hint, this is a directive. This is telling you, do this, please, compiler. You write it on this procedure here, inline this procedure, literal. It'll always inline it every time you call it. That's great. You could always have no inline saying, look, please do not inline this ever. Just do that. That's great. Now, sometimes you may think, look, I don't know what the default is, but in this particular case, can you inline it for me? Like inline it? You can do that as well. You can inline a procedure call explicitly. Okay? This is very, very useful to have. Now, sometimes you may say, look, it could be by default it's inlined, but in this particular case, can you please not inline it? So you could say explicitly no inline. Now, this may not seem very useful to the average person, but for certain topics, it's like, this is extremely useful to have, and extremely useful to go, look, don't inline this, like, or you could, it's just an override on the actual call itself. So, what can I do this? That's the question. Now, note this way. So I said on the call this can never be inlined, and I'm trying to explicitly inline it. It's now saying inline cannot be applied to a procedure that has been marked as no inline. This is, again, it's just one of those useful things. So can you see how it works? If it's been marked as inlineable, but you said explicitly don't do it, then it won't do it. If it's marked explicitly as no inline and you're trying to inline it, it won't be able to do it. Okay, so that kind of wraps up this demonstration. If you would like to try out Odin, you can go to the releases. This is for Windows, the releases are. You go on to Odin, github.com/odinlang /Odin. You can also build from the source directly for other operating systems. Do it such like that. You can visit the Handmade Network page where there's other fancy things in here, such as questions. There's the Wikipedia page on here, which has certain things. There's also the tutorial on here, which is very useful to go to. If I go onto the web here, there's another wiki page here as well, and it's a bit all over the place at the moment. This will be cleaned up very shortly, so they're all in a centralized place. There is also lovely frequently asked questions here about anything you may have. For instance, why is Odin an object-oriented language? And the answer is no. But Odin does support subtype polymorphism, which is kind of like inheritance to some people. So for instance, here's a base type. I can use the base type and be it derived. But this is one of the most amazing features about Odin, is you can use this base value. You don't have to have it at the beginning. And you can even use it on a live pointer. So you can have much more control over the memory layout. Okay, so someone's been being careful. So be very careful. I wasn't actually talking about you in particular. I was kind of just talking general. I'd be very careful in what I'm saying. So I'll just quote you out what you were saying. What the hell did I say in particular context that I hate Golang? I think I did not, nor did I say that composition is the shittiest thing. I'm just used to inheritance, and that's all. That's it. That's why we called individuals, because we have personal tastes. So first off, I wasn't criticizing your personal preference, actually. That's why I'm saying if you want whatever language you want to use and you're most productive in, please use that language. I'm not telling you should use one language over another. Okay? What I'm stating, and also I'm not saying that composition is better than inheritance, or inheritance is better than composition. All I'm saying is if hypothetically it was, I'm not talking about hypothetical people here, by the way. I'm actually not talking about specific usually. If it was a hypothetical person, if you were saying you do not like a language because it doesn't have feature X, but you can still achieve your goals with feature Y in that language, then, and you can still do it just as well, then it's not necessarily a criticism of language. It's more you have a personal style that you prefer that this language doesn't have. Okay? It's not saying that I'm being very clear here. It's not saying that style X is better than style Y because I'm just used to style Y. Or no, I'm used to style X rather than over Y, I mean, sorry, yeah. Okay? Does that make sense? Okay? Hopefully I wasn't trying to target someone in particular here, just I was trying to make sure I was being clear. Okay, good. Whew. So I think that's the end of this particular demonstration. I know I've been answering questions as along, but I'm going to actually answer a big now Q&A. I'm just going to, so please stop for that. Okay, great. So